Welcome to the deep dive. Today we're getting into deep learning. We got some really interesting material here, sort of laying out the basics.
Yeah, exactly. So deep learning, it's essentially a branch of machine learning, but a specific one that uses these things called neural networks.
Neural networks. Okay.
Right. And the idea, in a very high level way, is they try to process information in layers, sort of inspired by how our brains might work to ultimately make decisions.
And it feels like it's blown up recently. Is that right? Like suddenly deep learning is
Well,
everywhere.
absolutely. I mean, the amount of data we have now, plus the sheer computational power,
Yeah.
it's led to this huge surge. Some people are calling it a paradigm shift in computing.
Okay, a paradigm shift. So the core thing we're digging into today, based on our sources, is what makes deep learning different. Different from, the traditional machine learning methods.
Exactly. How does it manage to make these sometimes very complex decisions from data more autonomously, perhaps?
Right, so maybe let's ground this. Think about a typical machine learning job.
Mm.
Say, classifying images, like, does this picture have a car in it or not?
Good example. So the sources outline this kind of standard workflow. You start with your input, right, which is just a bunch of images.
Some with cars, some without, just mixed together.
Precisely. Then comes this step called feature extraction. This is where traditionally you try to identify the important characteristics in those images.
Okay, like the wheels or the shape or
Could
something.
be, yeah, those defining aspects. Then you feed those features into the actual machine learning algorithm, the classification part.
And that spits out the final answer. Car or no car.
That's the basic flow: input, feature extraction, classification, output.
So that middle step, feature extraction.
Yeah.
You said that's about identifying the important bits. That sounds pretty key.
It really is. And our sources point this out quite clearly. This feature extraction stage can be a real bottleneck in traditional machine learning.
A bottleneck. How so?
Well, the quality of your final model, your prediction,
Yeah.
it heavily depends on how good those features you extracted actually are. Better features mean a better result.
Okay, that makes sense.
Yeah.
If you tell the system exactly what to look for, like look for 4 round things at the bottom
Mm-hmm.
for tires, it's got a clearer path.
Right. And sometimes, if you're working with data that's already neatly organized, like in a spreadsheet,
Right, tabular data.
exactly. The features might just be the columns. Maybe you clean them up a bit, but they're basically there.
But I'm guessing it gets harder with messier stuff, like the photos we were talking about, or, I don't know, audio clips, text.
That's precisely the challenge. With that kind of unstructured data, images, text, audio, video, trying to manually define the important features beforehand, it gets incredibly difficult, almost impossible sometimes.
Yeah. How do you define the carness that applies to every single picture of a car?
Yeah.
Different angles, lighting.
Exactly. It's super hard to specify those universal rules or features manually. And this is where traditional machine learning historically kind of struggled with unstructured data.
Because it relied on people, on humans, to do that feature definition.
Yes, that manual, handcrafted feature engineering, it just doesn't scale well and often couldn't capture the complex patterns needed for really good performance on, say, images or natural language.
Okay, so let's sort of recap the main points from the material.
Yeah.
Deep learning uses neural networks, mimics the brain in a way. Traditional machine learning relies heavily on this manual feature extraction step,
And that reliance on manual feature work is a major limiting factor for traditional methods, especially with complex, unstructured data.
which is why maybe traditional approaches weren't amazing at things like image recognition or understanding speech back in the day.
That's a huge part of it, yeah. That difficulty in automatically finding the right features from raw data, like pixels or sound waves, was a big hurdle.
Right. So the sources set up this problem really well. They highlight the challenge.
They do. And while we don't get into the solution today from this material, the obvious next step, and the power of deep learning really, is how it manages to tackle this feature extraction problem much more effectively, almost automatically, you could say.
Okay, fascinating. It really puts that feature extraction problem front and center.
It does, and it kind of leaves you thinking, doesn't it? Consider all the unstructured data you see: daily photos, videos, text messages, social media feeds.
Yeah, it's everywhere.
So imagine the possibilities if we can automatically pull out the truly meaningful patterns and features from all that messy data. What could that unlock in fields way beyond just telling if there's a car in a picture? Something to mull over.